morning friends, welcome back to Relief Tutorials. Today we are going to start first chapter of science, matter in our surroundings. Easy chapter. First of all, what do you mean by matter? It's a very old term for us. Matter means anything that has mass and volume. Anything that has mass and occupies space, whatever you write. Occupying space means it has volume. Simple definition of matter: anything that has mass and volume means which occupies space. If you look around you, whatever you see or whatever you felt by one of your sense organ is matter. In your classroom you see blackboard, benches, books, chairs, tables. In our surrounding we see trees, many non-living objects, roads, poles, buildings, even the sand particles, clay particles, water, many things in our house like sofa, TV, dining table, pillows, curtains, some edible things, vegetables, fruits, common salt, wood particles. Anything you see around you all occupies space and has mass. Even some objects we cannot see, but we feel that they are present. For example, air present around us. We cannot see air or we cannot catch it, but it is present. It is made up of oxygen gas, nitrogen, carbon dioxide, helium, neon, argon, carbon monoxide, sulfur dioxide. Humidity means vapor particles. They are present around us. Yeah, they are small in size, but they are present. They have mass and they occupy space. So anything around us which has mass and volume are called as matter. Many examples of matter we can say. Can you set some examples which are not matter? Means either they are not having mass or they are not having volume or both. For example, thought. Thought coming into your mind. Emotion. Any type of emotion, thought, intelligence. Can you measure the mass of your intelligence? Never. It is just the feeling. Can you say that today I have 2 kilograms of thought? Obviously not. It is not having mass. It is not occupying any space. Cleverness. Such type of many examples which we can say that these are the feelings only. These are the properties only, but it is not having mass and it is not having volume. Such type of things are not matter. Examples of matter are infinite. Whatever the example you can write about matter, but which are not matter, that is important. So this list we have made which are not matter. Now, what is the physical? The topic from your textbook. Please take out your textbook. What is the physical nature of matter? First is each and every matter is made up of its particles. Matter is made up of particles. Simple examples we can understand, which is given in your textbook activity 1.1. You can take 100 ml of water in one of the beaker, okay, and dissolve salt in that. So when you take water, first of all understand water is made up of its particles. Consider these are the water particles. Now when you dissolve salt in that, you will see that salt gradually dissolves and disappears. So where this salt particle goes, salt particle take the place between the intermolecular space of water. There is some space present between the molecules of water already, and now you are adding salt. So the salt particles gradually dissolve and accumulate themselves between the space present between the water molecules. So what we can understand from this, that the salt which you have added having some considerable size that you can see it. But when you dissolve it, what happens? The salt particles disappears. It means what? The particles which you have added having some larger size that we can see them. But gradually those larger size particles converted into small size particles and disappears. In short, they are made up of particles. Every matter is made up of its particles. And second thing, these particles are very small in size. Particles of matter are very small in size. One of the activities given in your textbook that you take 100 ml of water, and in that you add 2 or 3 drops of potassium permanganate having pink color. So when you add 2 or 3 little drops, so the whole solution become pink. In 100 ml of water, just you have added either 1 or 1.5 ml of potassium permanganate. It gives you the pink color throughout the solution. So it indicates that the small size in 1 and 1.1 or 1.5 ml of potassium permanganate contains infinite molecules. So it spread throughout the solution and gives whole solution the pink color. Now out of this, let us take, this is 50 ml of pure water again in another beaker. This is 50 ml of pure water, and pour one more 50 ml from this having already potassium permanganate particles. So you add this solution here and again make it 100. So now again you will see that pink color again spread throughout the solution. So potassium permanganate molecule still divides and spread throughout the solution. Yeah, the pink color will be fainter. Pink color of the solution becomes fainter here. Now again take one more 50 ml of pure water and add 50 ml from this already faint solution. So you will see again the pink color again spread throughout the solution. Yes, the pink color again becomes fainter. So in this way you keep on diluting this, you keep on diluting the solution. You will see the potassium permanganate particles trying their best to spread through the solution. So it indicates that in just 2 or 3 drops of potassium permanganate, infinite number of particles are present, countless. Okay, so what I want to say, the particles of matter are very small in size beyond our imagination. You cannot imagine the size. They are such a small particles that you cannot imagine the size of the particle even. So particles, the two physical nature of matter you have to remember. Matter is made up of its particles, and particles of matter are very small in size. The question may be asked in your exam that write the physical nature of matter. So just you write the 2 points. Matter is made up of its particles, and particles of matter are very small in size. Now, what is the characteristics of these particles? Next topic from your textbook is topic number 1.2. Characteristics of particles of matter. How these particles behaves? What is the property of these particles? We know that every matter is made up of particles. Now we are trying to understand the properties of particles. First property, that particles of matter having space between them, which is called as intermolecular space. Particles are not stick to each other. Particles of every matter are not joined with each other. They are having certain space between them. They are slightly apart from each other. Many examples you can think that. Consider incense stick. One of the activity number 1.3 given in your textbook, incense stick. Okay, now when you lit that incense stick, what happens? The smell, the smoke coming out of the incense stick spread throughout the room. What does it indicate? That there should be some space present. There should be some space present between the air molecules in which the smoke particles of incense stick take the place. Consider this is room. These are the molecules of air already present. This is molecule of air. Now at one of the corner you are lighting incense stick. So the smoke coming out of that incense stick, this is considered incense stick here. The smoke coming out of that gradually spread throughout the room. It means what? There must be some space. If there is no space, then how these smoke particles accumulate themselves? But obviously they have some space. The recent example we have discussed, consider here is the water molecules. These are the red colored water molecules. Okay, and now when you add 2 or 3 drops of potassium permanganate, they spread throughout the solution and accumulate themselves between the intermolecular space. So this indicates that if they are accumulating themselves, there must be some space. So the space is present. What I want to tell you is what? The space is present. And see, the potassium permanganate particles accumulate themselves between the intermolecular space of water. This process of intermixing of two substances is called as diffusion. It's very important term. What do you mean by diffusion? Okay, before writing the definition of diffusion, one more thing we can understand from these, that these particles, see, incense stick is lit here. The smoke particles are coming from this side. Okay, so they are moving here and there. So they are moving and accumulate themselves between the intermolecular space. So one more thing is clear, that these particles are moving. Particles of matter are moving. The potassium permanganate drops you have added here on the top, gradually the particles of potassium permanganate moves by itself and take the place throughout the solution. So it again indicates the particles are moving. Okay, so before writing the definition of diffusion, second characteristics of matter, that particles of matter are continuously moving. Why they are moving? They possess, that is, they possess kinetic energy. The kinetic energy means the energy present in the particle due to its motion. The particles are continuously moving, so they possess what? Kinetic energy. And as the temperature increases, kinetic energy also increases. Kinetic energy increases with increase in temperature. As the temperature increases, kinetic energy also increases, and as the temperature decreases, kinetic energy decreases. So because of the two things to remember, there is intermolecular space and the particles are moving, and because of this the diffusion happens. When you add potassium permanganate drops here, for example, these are the two drops you have added. Okay, if they are not moving, then how they can be spread throughout the solution? One thing. Second thing, consider they are moving, but if there is no space between the particles, where they can be accumulated? So both the things are there. They are moving and there is a space, and due to which the diffusion occurs. Diffusion is one type of what? Intermixing. Intermixing of substance due to intermolecular space and motion of particles is called as diffusion. Intermixing of substance. Two substances got intermixed due to intermolecular space as well as the motion of the particles. This characteristics is called as diffusion. So here in this case what happens, that the molecules of incense stick are diffused in air. Potassium permanganate is diffused in water. For example, you are going by road and by bicycle, and there is some restaurant nearby on the roadside. So when you pass through, or when you pass from nearby of that restaurant, you will smell some food is cooking. So that smell comes to you. You are not in the restaurant. You are not in the kitchen of the restaurant, but the oil molecules, the oil particles liberated due to cooking of food are mixed up in air, diffused in air, and they travel with the air and comes to you, and then you can smell the cooked food. Many times, see the hot sizzling food, listen to me carefully, the hot food, the freshly made food in the bowl, still some vapors are coming out. So hot sizzling food, because of the temperature, hot food having more kinetic energy, the particles of matter having more kinetic energy, so they can easily get mixed up in air. They can travel a long distance because of the energy, and you can smell the hot food from certain distance. Whereas the food which is not hot, means after 15-30 minutes, the food is now become cool or cold, then what? Then the particles of matter is having less energy, so they cannot travel a long distance, so you cannot smell the cool food from certain distance. The smell of hot sizzling food can be felt at certain distance because of the kinetic energy of molecules are high because of the temperature. Okay, these are some examples of diffusion and also the kinetic energy. Third important characteristics of particles of matter, that these particles of matter having certain force of attraction. These are the two water molecules, these red colored, these are the two water molecules. Okay, these are the two water molecules, another water molecule. All these molecules are having some force of attraction. And when you add potassium permanganate, they also apply the force of attraction to that molecule also. Means particles of matter having some force of attraction. Consider these are the two particles of any one of the matter, and these are another two particles of another matter maybe. So this distance is more, so the force of attraction is less. The space is more, force is less. The space is less, the force is more. Means when they are coming closer, the force of attraction is higher. and when they are going away, the force of attraction is less. So in short, each and every particles of matter attract each other. This force of attraction is called as intermolecular force of attraction. This was intermolecular space and this is intermolecular force. The particles of matter always attract each other and this force of attraction is called as intermolecular force. More is the space, more is the intermolecular space, less is the force. Less is the intermolecular space, more is the force. So can we say that these two, means intermolecular space and intermolecular force, are inversely proportional to each other? So can I write intermolecular force is inversely proportional to intermolecular space. As the space increases, force decreases. As the space decreases, force increases. Means when they are coming closer, the more force is there. When they are going away, the force is less. So this is all about the beginning of the chapter. Two important topics we have covered. The first one was physical nature of matter. Matter is made up of particles. Second is particles of matter are very small. Then we have seen the particle nature, characteristics of particles of matter. First of all, the particles are having certain space between them, which is called as intermolecular space. Second, all the particles are always continuously moving, and these lead to it means it possesses kinetic energy. More is the temperature of the surrounding, more is the kinetic energy. So can I say kinetic energy is directly proportional to temperature? Also in mathematical language, is directly proportional to temperature, means as the temperature increases, kinetic energy increases. Temperature decreases, kinetic energy also decreases. Okay, and third characteristics, that particles of matter always attract each other. This force of attraction is called as intermolecular force of attraction, which is inversely proportional to intermolecular space. Now regarding this, we have some blue color question given on page number 3. Look at that textbook. The first question is, which of the following are matter? Chair, made up of particles, matter. Air, matter. Love is a feeling only, so it is not made up of any particle. It is not occupying space and it is not having mass, so it is not matter. Then we have smell. See, the smell of flowers. For example, smell of flowers. So smell of flower is not made up of any particle. It is not having any mass. It is not occupying any space. So that is not matter. Love is not matter. Hate is again a feeling, not matter. Almonds, matter. Thought, no. Cold drink, yes, matter. Smell of perfume. Now smell of perfume is made up of some particles. You know that particles coming out of that perfume bottle. So smell of perfume is a matter. Second question, give reason for the following observation. The hot sizzling food reaches you several meters away, but to get the smell from the cold food, you have to go close. Recently we have discussed that when the food is hot, the temperature is higher, and as the temperature is higher, it possesses more kinetic energy. Particles of matter possess more kinetic energy, so they can travel up to certain distance by diffusing themselves in air, and the food smells good from certain distance. But when the food becomes cold, it becomes cool, so the temperature decreases, and so the kinetic energy also decreases. So particles cannot diffuse easily, and they cannot travel a long distance, so you have to go certain distance close. Third, a diver, not driver, it is a diver diving into the swimming pool. A diver is able to cut through water in swimming pool. What property of matter does this observation shows? If you think about the swimming pool like this, for example, it's an example of diffusion again. Here is a swimming pool made up of water. Okay, it's having the water. Now when you dive, what happens? You go through water. It means what? There must be some space available, then only you can enter it. So it gives the example that the water molecules have intermolecular space between them. So this is the best property, shows that the particles of matter having some space, so the other particles can mix in that. So the third question, diver is able to cut through the water. What does this observation shows? It shows that the particles of matter possess intermolecular space between them. Okay. Fourth question, what are the characteristics of particles of matter? We have seen the characteristics of particles of matter here. 1, 2 and 3 characteristics are there. No need to waste the time again. Okay. So this is all about the beginning of the chapter. Please follow this, and it's very easy part. So please try to remember it. Best of luck. Next we will see in the next lecture.